Continuing our work with arc length, we are going to now find angle measure and also review arc length in general. So with this example, they're saying you have a horse. So I'll assume the horse is right here. And it's attached to an 8-foot long rope. It's allowed to rotate around wherever it's penned in with that rope 28 feet. So that creates an arc. I want to now know the angle at which that central angle at which that horse has been rotating around. So I'm going to use that arc length formula, that proportional relationship yet again. So looking at this, I know in this case the arc length is 28. I'm always comparing that to the entire circle, even if the entire circle picture isn't given. So that's going to be the circumference, which is 2 times pi times r. So if you double the radius, you get 16. I just left the pi in there. I know it says the nearest degree. So if you want, you can also put that in your calculator and you would get 50.265 if you don't like the pi. And this time we don't know the central angle, so that's the variable we're looking for. So that's the x out of the entire circle is 360. So we took this arc length formula. Instead of finding the arc length, we're using it to find the angle. Cross multiplied. All these problems you can cross multiply. And I divided out the 16 pi, or technically I divided by 50.265. And that angle is going to be 201 degrees. So look at your picture. Does that make sense? Sure. More than half of the circle the horse rotated through. 201 is a fair estimate. Going down to the next example, this is more what we've been working with the last couple of days. Just finding the arc length. This one's slightly different though. I want to review that in terms of pi and also what central angle they gave you. So I want the arc length of the shaded arc. So from G all the way to J, the major arc there. So all of this. In this case, I don't know the central angle measure. I know this is kind of shaded, sorry. But I do know part of the non-shaded is 60. So using my formula, I do one other piece of information before just putting in the angle. I did 360 minus 60. That's how I got 300 here. So you might have to manipulate a little bit before you go right to your formula. That was the manipulation I did. I'm still finding arc length, so I put that as S. And again, it's all about circumference. So circumference is 2 pi r. So I put in, I don't know if you can really see that, but that is 8. So again, the radius is 8. That's how I got 16 pi. It says in terms of pi. You do not want to put this in your calculator. So, sorry, you don't want to put the pi in your calculator. So I did 16 times 300. So I got 4,800, pulled the pi up with it, 360s, and I just divided out the 360. Only putting this portion in my calculator, it reduced to 40 over 3. Then I can put the pi next to it. Need to find our next part. Okay, so here is, so here's the back. So moving on from circles and arc length and angle measure, we're going back to rectangles and perimeter. So it says you have a rectangular site. So I drew a little picture. So this engineer doesn't have a measuring tape. So what he or she has is a wooden pole they're using to measure. So we're saying that pole has length of X. The length of the rectangular site is 2 pole measures increased by 3 feet. So there's your 2 times whatever that pole length is plus 3 feet. Opposite sides equal. The width is 1 pole measure, so 1x, decreased by 4, so minus 4. So those are the same. All they want you to do is write an algebraic representation in terms of pi for the perimeter. So again, the perimeter, I'm just combining like terms. So if you want, and it's going to be kind of messy here, if you want to write all this out, that you're adding every single piece here, that'd be helpful. But in terms of like terms, I have 6 x's, so I combine those for 6x, and then the value of the numbers ends up being -2. Let me know if you have any questions.